Hi guys, welcome back to my YouTube channel. Let's crack real math. My name is Viraaj, and in this video we'll be having a look at arithmetic progressions. So I am back after a break, so let's just hope that I am back with a bang. Without any further ado, let's begin arithmetic progressions. So before I start solving examples, let's just take a look at the brief overview. So what exactly is an arithmetic progression? An arithmetic progression is something like this. For example, let's say 4, then 8, 12, 16, 20. Suppose this is a progression, and an arithmetic progression is a progression that has a common difference. In this case, the common difference is 4, because you would eventually add 4 to 4 to get 8, and the same applies as it goes on. 8 plus 4 would give you 12, then 12 plus 4 would give you 16. So the reason it's common difference is because between each terms is the same number that's being added or subtracted. So in this case, the common difference that we call as D is equal to 4. Another component of arithmetic progression is your first term, and we represent that with A. So A, that's our first term, which in this case is 4 as well. Now one thing to note is that arithmetic progressions can be the other way around as well. It could decrease. For example, it could go from 9 to, let's say, 6, to then 3, to then 0, then minus 3. In this case, our D is minus 3 because from each term you're subtracting 3 to get the next term. And our A in this scenario would be 9 because that's our first term over here. So these two components are the most important ones and the ones that they're most likely to ask questions on. So for all of this, we have a few general formulas. The first one we have is nth term is equal to A, that's your first term, plus n minus 1d. So over here, d is your common difference. Your A is your first term, your first number, and your nth term is simply, for example, a particular value for a supposed term. For example, n, let's say, is like we have a progression and I want to find the 33rd value. So the 33rd number of that progression is what I want to find, will be the nth term. Suppose of this progression 4, 8, 12, 16, 20, I'm not sure what the 33rd term is. Let me just make up and say it's 84. So that's simply my n. This would simply be 33 because that's the term I'm looking for, the 33rd term, and the value of that 33rd term would be my nth term, which in this case I made up 84. Of course that might not be correct, but just for time purposes I just made that one up. So n is simply the term that you're looking for, and the nth term is the value of that particular term you're looking for. Another key formula this brings us to is this: your first, your second, your third, your fourth. Let's say these are your terms. Your first term is always going to be A by itself. Your second term is always going to be A plus D. Your third term will always be A plus 2D. And your fourth term would be A plus 3D. Likewise, your fifth term would be A plus 4D, your sixth term would be A plus 5D, your 99th term would be a plus 98d. One easy way to remember this is just to subtract 1 from the term. So suppose you want to find out, they say the 43rd term of a particular progression is 96. Let's just make that up. The 43rd term of a particular progression is 96. So all you would do, you would write a plus 42d, I subtracted 1 from 43, is equal to 96. And in this case, they might have given you your a, or they might have given you your d, and you might have had to find one of the unknowns. And the final formula that you need to know is the sum of a progression. Sum, or you can actually write this as Sn. The sum of n terms. This is the formula, goes as n over 2 brackets 2a plus n minus 1d, where again your d is your common difference, your a is your first term, and your n is simply the term that you're trying to find. So suppose they said to you to find the sum of a particular progression until 30 terms, or the first 25 terms. So your n will simply be your 25. What sum of terms mean is, if I take back to this progression I made, 4, 8, 12, 16, 20, we know this is a progression, but they can ask you to sum all of this up. So in this case, it would be the sum of the first 5 terms, which is 4 plus 8 plus 12 plus 16 plus 20. And you can then press this into your calculator and find out what the sum of n terms of the first 5 terms in this case would be. They can also tell you the particular value that it would give to you, and they would then ask you to find maybe how many terms does it take. So for example, they could say the sum of n terms is 110. How many terms did it take to get 110? So those are type of questions that you can come across. So without further delay, let's look at our first example. Right, so this is our first example. It says the 9th term of an arithmetic progression is 22, and the sum of the first 4 terms is 49. So we have an a part and a b part. The a part says find the first term of the progression, and the common difference. And the second part of the question says the nth term of the progression is 46. Find the value of n. So let's draw our information out of this question. It says the 9th term of an arithmetic progression is 22. So the 9th term, as soon as you hear that, you should know that the 9th term of an arithmetic progression is a plus 8d. And it said that it's 22. a plus 8d equals 22. We have an equation, but we don't know our a and we don't know our d. And the question also says that the sum of the first 4 terms is 49. So what they're trying to say is that the sum, that's n over 2 into 2a plus n minus 1d, is 49. Now we know our n because it said the first 4 terms, so you just simply substitute your 4 into the places of n over here and here. So if you do that, you would have 2 into 2a plus 3d equals 49. Just jumped a few steps here, but if you put 4 over here in n, you know 4 divided by 2 is 2, and if you put 4 over here, we have 4 minus 1, that's 3, and you multiply out with this bracket, that's 3d. And we can simplify this equation further. We can expand the brackets. If you are not comfortable in expansion of brackets, you can watch my video on expanding single, double, and triple brackets. So expanding this, we have 4a plus 6d equals 49. Again, we don't know our d, we don't know our a. But if you look carefully, we now have 2 equations. 4a plus 6d equals to 49, and the equation we derived earlier, that's a plus 8d equals 22. And what this looks like is a simultaneous equation. So all we have to do now is solve these two simultaneously. If you're not comfortable solving simultaneous equations, then you can also watch my previous video on solving simultaneous equation using both substitution and elimination method. In this case, we will use elimination method. So let's times this equation by 4, because we want this a, let's eliminate the a with the coefficient of 4. So we now have 4a plus 60 equals 49, and timesing the second equation by 4, we have 4a plus 32d equals to 22 times 4 should be 88. And now we can eliminate our a, subtract, so we have nothing over here. 6 minus 32, that should give you minus 26d, and 49 minus 88 should give 39. Let me just confirm. 49 minus 88, yep, gives minus 39, goes to minus 39. And to find your d, all you do is take this minus 26 to the other side, divide it by minus 39, and minus 39 divided by minus 26 is positive 1.5, because the minus will cancel each other out. So we have our d. But the question also said that we also need to find the first term as well as the common difference. So if we have our d, all we have to do is substitute our value of d, let's say this, into one of the equations. Let's say the second equation. So a plus 8 into 1.5 equals 22. A is 22 minus 12. A is 10, because 8 times 1.5 gives you 12, and if you take the positive 12 to the other side, it becomes minus 12. So 22 minus 12, and then your a is 10. So the a part of that question, done and dusted. The b part says that the nth term of the progression is 46. So from the equation we know, or the formula rather, we know that nth term is equal to a plus n minus 1d. It's saying that the nth term of the progression is 46. Find the value of n. So they've even given us a hint that this n is what we're trying to find. So let's put this 46 here into nth term. So we know 46 is equal to 10 plus n minus 1 into 1.5. Our a, as we found out from the a parts, is 10, and our d is 1.5. So from here it's just a simple algebraic equation. We have 46 equals to 10 plus 1.5 n minus 1.5. I have 1.5 n equals to 37.5. So 10 minus 1.5, that gives 8.5, and then 46 minus 8.5 gives 37.5. And to solve for n, just take 1.5 to the other side, divide 37.5 by 1.5, and your n should be 25. And that is the answer, the complete answer rather, to the first example. Right, on to the next example I have. This one says that the first term of an arithmetic progression is 61, and the second term is 57. The sum of the first n terms is n. Find the value of the positive integer n. So let's derive our information. It says the first term of an arithmetic progression is 61. So a is 61. And it said the second term is 57. And we know that second term is simply a plus d equals 57. And because we know our a to be 61, we can get d. So our d is simply d equals to 57 minus 61, because if our a is 61, you take it to the other side and subtract, and d is nothing but minus 4. So in this case our d is negative. That means as the progression continues, the numbers are actually decreasing. You're subtracting 4 from the previous term. And the other information is that the sum of the first n terms is n. Find the value of the positive integer n. So what it's trying to say is that the sum until a particular amount of terms is equal to the same number of terms. So it's like me trying to say, for example, the sum of the first 20 terms is 20, or the sum of 29 terms is 29. It is a rare case, but it is possible. So with our formula, we know that n over 2 brackets 2a plus n minus 1d is equal to the sum of the terms, and which in this case is also n, so equals to n. Now all we have to do is substitute our a and our d values and see what kind of an equation we can derive. So we will have n over 2 brackets 122 plus n minus 1, okay, so this would be minus 4n plus 4 equals n. So basically what I did was that I put 61 over here, so 2 times 61 would give me 122, and since our d is minus 4, so minus 4 times n would give me minus 4n, and then minus 4 times minus 1 would give me 4, because the minus 4 eventually cancel out. We can simplify the inside still, so we have n over 2 brackets 126 minus 4n equals to n, because 122 plus 4 is 126. And now we can expand the brackets. We would have 126n minus 4n squared all over 2 equals to n, because if I multiply this by this, I would have n times 126, which is 126n, and n times minus 4n is minus 4n squared all over 2. We can cross multiply, and cross multiplying would have 2n equals to 126n minus 4n squared. I can take the minus 4n squared and 126n over here, so that I can have a positive coefficient of n squared. That would give me 4n squared minus 1 to 4n, because 2 minus 1 to 6 is minus 1 to 4, equals to 0. We can solve this by factorization. So 4n into n minus 31 give me 0. 4n equals to 0, or n minus 31 equals to 0. My n is 0, or my n is 31. So all I did here is I just simply solved by factorization. If you are not confident solving by factorization, you can watch my previous video on solving by both factorization and the quadratic formula. So the question said find the positive integer n, and because one of our values is 0, that's not possible, so this is not a possible answer. Our final answer will be that n is equal to 31. That's the answer to that question. And okay, just a second guys. Right, so on to our final example for this video. It says, in an arithmetic progression, the sum of the first 10 terms is 400, and the sum of the next 10 terms is 1000. Find the common difference and the first term. And this is a challenge question. challenge question. So pause the video and have a go at this by yourself, and then resume the video to see if you are correct or incorrect. If your answer is incorrect, please do take note of your mistake. So let's begin. It says in arithmetic progression, the sum of the first 10 terms is 400 and the sum of the next 10 terms is 1000. Find the common difference and the first term. Okay, so it says the sum of the first 10 terms is 400. So with our formula, n over 2 into 2a plus n minus 1d is equal to Sn. That's the sum of our terms. We know that in the first piece of information our n is 10 and our Sn is 400. So 10 over 2, if I substitute n with 10, that will give me 5. So 5 into 2a plus 10 minus 1, that's 9 times d, so plus 9d equals to 400. And expanding and simplifying the left hand side, I would have 10a plus 45d equal 400. That's one equation we've made. And the other piece of information from the question is that the sum of the next 10 terms is 1000. So if the sum of the next 10 terms is 1000 and the sum of the first 10 terms is 400, that means the sum of the 20 terms altogether is 1400. What they're trying to say is that the sum of the first 10 is 400 and the 10 after that by itself is 1000. So of the whole 20, it's 1000 plus 400, which is 1400. So again, n over 2, the same formula we'll use, but this time instead of n being 10, our n will be 20. So 20 over 2, that gives you 10 into 2a plus n minus 1d. Our n is 20, so 20 minus 1, that's 19. d equals to 1400. Simplifying this, we have 20a plus 190d equals to 1400, and this is another equation that we have. And again, we have two equations. We have this equation over here and this equation over here, and we can solve them both simultaneously. So 10a plus 45d equals 400, and I have 20a plus 190d equal 1400. I can times the first equation by 2, so I can have the same coefficient for a. Timesing that by 2, I have 20a plus 90d equal 800, and then the second one obviously 28 plus 190d equals 1400. Upon subtraction, I have this would cancel out, obviously no more a. 90 minus 190 is minus 100d equals to 800 minus 1400 should be minus 600. So let's confirm that real quick. Yes, it is minus 600. And now to solve for d, just take it to the other side. Divide minus 600 by minus 100, and d would be 6, positive 6, because the minus will cancel each other out. We have our d to be 6, so all we need to now find is our first term, that's our a. Common difference is 6, and first term is what we want to try to find. So we can just substitute this into the second equation. So 20a plus 190 into 6 equals 1400. 20a equals to 1400 minus 190 times 6, that should be minus 1140. 20a is equal to 1400 minus 1140, that should be 260. Confirm real quick. Yep, 260. A is 260 divided by 20, which is nothing but 13. So our first term is A, which is 13, and our common difference is D, which is 6. And that is the answer to that particular question. And that brings this video to an end. Thank you for watching, guys. Please do not forget to perform an LSS, that is like, share and subscribe. Please feel free to comment below for any feedback or any questions you may have. Thank you for watching. Have a nice one.